Every second, high-speed presses slam brass into shape inside ammunition factories, producing millions of rounds a day. A single defect buried in that volume can mean catastrophic failure. This is a $25 billion industry running on one of the most unforgiving production systems ever engineered. And the reason these plants operate the way they do goes back further than you'd expect. In the mid-19th century, ammunition was still a handcrafted product. Soldiers cast their own lead bullets and hand-rolled paper cartridges, meaning no two rounds were ever identical. But the rise of massive industrial armies transformed this manual craft into a high-stakes engineering challenge. To feed thousands of rifles on a battlefield, military forces demanded millions of rounds that functioned without fail. The solution was not simply better machinery, but the introduction of absolute standardization. Early factories abandoned paper and began drawing cartridge cases from solid brass. This established identical dimensions for every casing and bullet, ensuring complete interchangeability. Wartime mobilization forced these early plants to think strictly in terms of high throughput, refining processes to produce identical parts at a massive scale. Modern ammunition facilities inherit this exact industrial architecture. The relentless drive for high-volume throughput and absolute dimensional consistency that shapes today's automated factories is a direct legacy of this 19th century push for standardization, proving that the logic of the past still dictates the rhythm of the modern assembly line. A modern cartridge is not a single piece of metal, but a highly coordinated, self-contained system of 4 distinct components. Each element plays a precise role in an engineered sequence that lasts only milliseconds. The cartridge case serves as the structural foundation, sealing the chamber of a firearm to direct expanding gases forward. Pressed into the base of this casing is the primer, a highly sensitive chemical cup designed to ignite under mechanical impact. This sudden spark instantly triggers the propellant, a dense chemical powder that burns rapidly to generate intense gas pressure. At the tip sits the projectile, the balanced metal core launched down the barrel. Sustaining the output of millions of these rounds daily requires an unbroken, massive stream of raw materials. Facilities rely on constant shipments of specialized copper-zinc brass alloys for the cases, lead and copper jackets for the projectiles, and highly refined nitrocellulose for the propellants. This extreme scale makes the manufacturing ecosystem vulnerable to supply chain shocks. A disruption in raw copper mining or a shortage of propellant chemicals can instantly paralyze a factory. To survive these bottlenecks, modern plants must carefully balance virgin material streams with recycled metals and reclaim spent brass. Securing these inputs is the essential first step before the high-speed machinery can begin its work. The moment raw materials cross the factory threshold, they enter an unbroken, highly synchronized machine ecosystem. The plant operates as a single, massive, connected chain designed for non-stop momentum. Coils of brass alloy and lead wire feed directly into the intake, propelled forward by a network of high-speed progressive presses, transfer dies, robotic feeders, and motorized conveyors. The factory floor operates as a mechanical choreography where raw metal undergoes a rapid, violent series of transformations. In a fraction of a second, heavy presses punch and stretch the brass, drawing it into hollow cartridge cases. Simultaneously, adjacent machinery shapes the lead cores and cold draws copper jackets, marrying them into balanced projectiles. High-speed pneumatic feeds route these components toward the assembly hub, where they align with primers, receive precise propellant charges, and are assembled and cleaned. At this scale, manual handling is completely impossible. Human hands cannot match the rhythm or the absolute consistency required to sustain an output of millions of rounds a day. High-speed automation is the only way to keep the production flow steady and controlled. On this floor, operators act as strategic guardians of the system, monitoring digital dashboards and ensuring the machinery never loses its rhythm. But this extreme speed and volume introduce immense relentless pressure. When a single assembly line produces thousands of rounds every minute, a microscopic error at any stage can ruin an entire production run in seconds, or worse, lead to a catastrophic malfunction in the field. This raises a fundamental challenge. In an environment moving too fast for human eyes to track, how does a factory ensure that every single cartridge is absolutely flawless? Every single cartridge must prove its integrity before leaving the assembly line. Automated inspection systems stand as the final barrier, processing up to 300 rounds per minute. High-resolution machine vision cameras and three-dimensional laser gauges inspect the physical exterior, measuring case length and mouth roundness to within fractions of a millimeter. For hidden defects, high-speed X-ray units scan the sealed cartridges, verifying the exact primer seating and the calibrated propellant weight. Any cartridge showing a microscopic deviation is instantly blasted from the line by a high-pressure pneumatic diverter. This physical rejection is backed by a digital ledger. Every production run is assigned a distinct lot number, creating an electronic batch record that links every completed round to its specific material source and machine run. Quality control technicians oversee these systems, running gauge checks and analyzing ballistic test samples in fortified chambers. This relentless verification is an institutional commitment to safety. Through strict lot control and constant automated monitoring, the factory preserves the exact history of every round, ensuring that industrial speed never compromises field reliability. Inside the plant, reliability in the field depends entirely on discipline on the floor. Operating a facility that processes explosive mixtures and volatile propellants requires absolute human control. Historical industrial accidents, including a fatal 2017 primer cell explosion at the Lake City plant, forced the ammunition sector to reshape its safety protocols, turning hazardous manufacturing into a study of systematic risk mitigation. Today, safety is built directly into the factory layout. High-capacity local exhaust ventilation systems capture toxic lead dust at bullet-forming stations, while isolation barriers shield the floor from high-energy zones. Safety staff, maintenance crews, and line operators navigate the floor under strict training guidelines. They wear specialized personal protective equipment and enforce rigorous lockout-tagout procedures during machinery service. These strict environmental controls protect the workers while preserving the tight tolerances of the high-speed machinery, proving that human discipline is the ultimate foundation of industrial reliability. A flawless cartridge is useless if it cannot reach its destination securely. On the packing floor, automated systems funnel finished rounds into heavy steel cans and custom cardboard boxes. This packaging extends strict lot accountability past the assembly line. Every box receives a two-dimensional barcode, linking the cartridges directly to their raw material origins. To prevent unauthorized access, packages are sealed with tamper-aware tape before robotic arms stack them onto standardized military pallets. This downstream chain is what makes the plant's immense scale operationally real. Logistics staff act as the final human interface, loading pallets onto secured trucks and rail cars destined for military depots, law enforcement agencies, and authorized commercial markets. Moving these volatile assets across global networks requires strict compliance with international transit standards, protecting the cargo from the warehouse to the front line. Scale is maintained not through chaos, but through flawless coordination. The non-stop rhythm of the ammunition factory relies on this final silent system of distribution, ensuring that every round performs exactly when it is needed. Today, global demands push these automated lines to unprecedented limits. As machines run non-stop, the line between raw metal and ready ammunition must remain flawless. In this relentless cycle, speed is nothing without absolute precision. Share your thoughts in the comments.